And hello, here we go to demonstrate the MIP, or mobile inverted pendulum, meaning that we're heavy up here and, well, it's kind of heavy down here, but let's think of a pendulum as something that swings like this, right? Let's do the arm motion. If you're a pendulum, you swing like this. If you're a MIP, you invert that and you swing like this, like up toward the ceiling. The opposite of a grandfather clock. Take a grandfather clock, turn it upside down, and this is what happens. When you put a little gyro on there, 3-axis gyro, this is the Bluetooth controller for it, which has a little 18 Mega Mini Pro board on there. The Wi-Fi component to that, excuse me, not Wi-Fi, Bluetooth to Bluetooth. The nunchuck to control it, 3.3 volts. And this thing, which drove me nuts, because if you plug in a very power efficient low current draw entity such as this setup right here, you're going to pull about 20 milliamps continuously. Modern LiPo batteries say, 20 milliamps, I'll just go to sleep, and they turn off their output. And this just goes blank and dead. Hence, I had to find something on the wonderful World Wide Web that would go out every 10 seconds. You'll see a green LED light up here every 10 seconds. There it goes. And take a hit for like 160 milliamps. The battery says, oh, I'm going to wake up again. And it continuously does that at a power cost of 160 or 120. I think it's 160 milliamps every 10 seconds. So you figure that out per hour, and then you can do the calculation for the old milliamp hour rating and so forth and so on. However, it's based on a 555 chip, which is a timer turned into a, and I've seen these, I've seen these designations on data sheets for many years. And I wondered, what the heck are the electrical engineers thinking about when they say something like an astable multi-vibrator? Okay, let's say that again. Astable multi-vibrator. Big fancy word for, it's an oscillator. It goes on and off, oscillates back and forth, back and just on, just off, okay? That's it. That's the entire circuitry that I had to figure out how to put on a small breadboard with 2 USB connectors. There's the wiring on the back. Nice job, I think. And that is purely to function as a keep alive for, sorry about all the jumping around here, for the battery. So when that connects to the MIP, give it a second or two here to do its winky blinky thing. We take the nunchuck and, oh, it's not waking up. Boy, that's always embarrassing when it does that, Come on, what's going on here, guys? All right, that's supposed to move the MIP all over the place. I don't give up that easily. You're going to get a full demonstration of this puppy. All right, why isn't this waking it up? It's not registering. Okay, so let's take the MIP, turn it off, and I'll show you how it starts up. Good opportunity, rather than any kind of failure. So we turn it on. Hopefully it goes out and it connects to the Bluetooth over here. There we go. I saw it. There's the light. Now, the thing with the MIP is you have to stand it up. And this design is from Joop Brokking in the Netherlands. This guy writes code like you would not believe, and hardware. See, stood it up. And I'll push it backwards. And of course it wants to balance itself, so it's going to keep on moving back and forth and back and forth. Oh, there we go. All right, so the nunchuck controller backwards. Let's do a little rotation here. Oh, and I always almost kind of fall off the counter when I try to do this with a camera. Okay, so, and that's this unit down here controlling the MIP. I hope it isn't making you too nervous that it's, you know, about ready to fall onto the floor. So there we go. Bluetooth, big power supply to power that. Keep alive circuit, MIP or mobile inverted pendulum. And why did I do this? Oh yes, and by the way, the blue plastic here, the red plastic here, both of those were designed by me and printed on the Prusa 3D printer right over there. All, you know, kind of sitting on the kitchen island here, which is not where it's supposed to be. It's supposed to be down in the basement through that door, but somehow it ends up here all the time. Anyway, this has been way too long of a YouTube presentation. I hope you had fun. Yes, I'm eating lunch while I'm doing this. This is also to explain to prospective employers that, yeah, I know what the heck I'm doing, so just hire me. Oh, I shouldn't probably show you this, but I'm doing that too. This is 300 LEDs running off of a little Wemos ESP8266. That sounds really sexy, doesn't it? That's this guy right here, which is about as big as my thumb. That does Wi-Fi, not Bluetooth, Wi-Fi. That was a power supply that I thought I needed, but because it was 2.5 amps, but it actually runs off of a little cell phone adapter, as you can see down there, which is about 1.5 amps. 5 volts, 300 RGB LEDs, NeoPixel, running another gentleman's program. I don't remember his name. I should give him credit on this, but I guess I could write that down in the section below. If you want to know anything else about what I do or how to put things together, I'm more than happy to help. Just shoot me a message and I'll get back to you. Ciao for now. Have a great day in wonderful cold Minneapolis. What are we at? We're negative 3.3, going down to a wind chill of probably minus 58 degrees Fahrenheit tonight. Take care.